Now, let's modify our donut and our setup. First off, we're going to add over here a resistor. This way we can take measurements across here as our input voltage across the resistor, which is 33 ohm, on the positive. Here's our negative, our square wave that's coming in. We will be watching that with scope 1, which is the scope on the left. Here, now we're going to close this loop. What we're going to do here is we're going to add a bridge rectifier. Off that bridge rectifier, we're going to add a 33 ohm resistor. And as well, we're going to have scope number 2, the scope on the right, monitor this. I'll then take readings of voltage across the 33 ohm resistor and calculate wattage. I'll also take the voltage across the 33 ohm resistor here and calculate the wattage used here. The two amp meters you're about to see are connected here, and as well are connected here between the resistor. Now, the yellow meter is the input amperage. The amperage being used. This meter here is the amperage that's coming out. We'll now take a measurement of the resistors, which you will see is one here. This resistor here is the resistor that is coming from our 9 volt supply and into our primary driver coil. This resistor here is the resistor that's connected to the bridge rectifier. Now I'll take voltage measurements off of this one, which is our driver. .21, 0.20. Now the other 0.47. Let's try it the right way. 0.51, 0.49. 0.51. Big difference there. Okay, let's begin by talking about our first, third, and fourth quadrant driver, as seen on here. So you can see this back EMF is quite strong here, and it has a definite straight up and down line. There doesn't seem to be any capacitance in there or anything. It's a good square wave with lots of back EMF. Next thing we're going to do is we're going to look at the scope on the right, which is the output scope, or here on the second quadrant through a bridge rectifier. The scope is connected here and here across the 33 ohm resistor. Here we see the results of the second resistor coming off our output coil. It's very hard to stop it from moving. There's a very interesting forward wave on the top, waves coming down the bottom. Let's do an XY. Here's how our XY looks. Lessen up the voltage a little. We're at a time divider of 0.2 milliseconds. Our voltage divider is at 0.5. Again here, quite a bit of movement in that. This is what our secondary coil, or our driver coil on quadrant 2 is putting out. Here's what we've determined from our experiment. We came in here, we notice we have 6 milliamps showing on the amp meter. we have a resistor here that's showing 0.21 volts. It's a 33 ohm resistor. Our frequency coming in has been changed to 3.57 kilohertz. Over here on our outside, section B, we'll call section A the inside, section B the outside. Outside we have a pattern or a wave that has a slope to it and down, and here we can see we have 14.9 milliamps with our amp meter, 0.5 volts, and our voltmeter with the same type resistor, 33 ohms. We'll now calculate this out. In section A, we will see that our volts times our amps will give us our watts. 0.21 times 0.006 equals 0.00126 watts. Here, section B, 0.5 volts times 0.0149 milliamps or amps equals 0.00745, for a difference of 0.00619 watts more on this side than there is on this side. Here though, the voltage is only 3 volts. This is the problem of getting it back over here.